Torque and angular momentum. Okay, so just like we have the force, that is F equals to ma in linear motion. Similarly, we have the formula for rotational motion. If we talk about force, then F is equals to I into alpha. So I is the moment of inertia of the body. It depends on the axis of rotation, and here m is the mass. So that's the analogous formula. But here I am talking about torque. So rotational force I am talking about. So we talk about rotational force. We call it moment of force also. So moment of force is the same as torque, so you can call it torque also. So more prominently we use the word torque, and that's the symbol for torque, and that's equals to R cross F. So let us look at this figure. This is your R. First of all, what this R is? This R is the position vector. Where? So what are the 2 points that it is joining? This position vector. Obviously this is your origin, and here you have axis of rotation. So here you have axis of rotation. Okay, that's your axis of rotation. And this point is where force is applied. So always you have to join 2 points, and that's your position vector. So which 2 points? The point from where you have axis of rotation, and the point where force is applied. This is the point where you are applying the force. Axis of rotation, definitely it's a line, axis is a line, but this is the point. So this point where, so point of where you are applying the force, point where force is applied, this point. So this is the point P where the force is applied. Okay, now in this the diagram that we have is that the force is applied in this direction. So you know the formula, torque is equals to R, magnitude of position vector R. This is your magnitude R, then the magnitude of the force. What is the magnitude of force? This is your magnitude of force. Okay, and then sine of theta, angle between R and F. So how will you find the angle between R and F? So so this is RF sine theta. So how do you find the angle between R and F? Will you consider this angle? Is this theta? Yes or no?
No, sir.
No. Okay. What about others? Veena?
No,
No,
sir.
sir.
Okay.
No, sir.
This is not the angle. Okay, then Veena, tell me which angle you
No,
will take.
sir.
Which angle you will take then?
In figure, theta is there, na? FP
Don't
or
look
फिर
at the figure.
theta.
We are not discussing the figure. Forget the figure. I am taking an example. What is theta? Theta is the angle between R
Two
and F.
vectors.
Between the two vectors. So isn't it the angle between R and 2F? R and F? Isn't this the angle between R and F? Can't we take this angle?
Sir, join the tail of R vector with the tail of F vector, and that will be the theta.
Okay. Okay. Good. So this F vector, so I need to bring this R vector over here. Huh? Here.
Yes, sir.
Okay. Good. So student, this is what we need to understand, that this theta will not be considered. Theta is the angle when the the tails of two vectors are joined. So Veena is absolutely correct. So this is the angle that we are going to take between vector R and vector F. Yes, absolutely. Good. So, and then as I have vector over here, so this is the magnitude of that vector, and now the direction. How will we tell the direction? With a unit vector, multiplying this magnitude with a unit vector, that is n cap. And this n cap is perpendicular to the plane containing the vectors R and F. Okay? So, this is what torque is. Okay. Now, what is this? Okay, I know the magnitude F. And what is this? Suppose R sine theta. If I write only the magnitude, then it is F into R sine theta. What is R sine theta? This is your R. Okay. This is your F. So this direction of the R, this vector R, if it's a free vector, you have taken the free vector over here. Okay. You have brought it over here, this R vector. It being a free vector. Now, so this length is your R, right? Now what is R? This angle is theta. You extend this. What do we call it, Karthik? This line. This line. What do we call it? This line. Yes. What do we call this line? Karthik? Who else will tell? What do we call this line? Any of
Which
you?
line, sir?
We are talking about this line.
Axis of rotation.
No, good try, but that's the axis of rotation is at O. Okay, and the axis of rotation is perpendicular to this plane. Okay,
Line of action.
line of action. So this line is where you are applying the force. So that is line of action. So this line is line of action, this whole line. Okay. So if you extend this force, means the direction, this line is your line of action. We call it line of action. Okay. Now this angle is theta, and these are vertically opposed angle, because here you are extended this position vector direction, and here you are extending the force. So the angle is vertically opposed angle. This angle is theta. Now from the axis of rotation, means that from point O, draw a perpendicular. So the perpendicular distance we are going to take. So this is tau is equals to f r perpendicular. We write this formula. So what is the meaning of this r perpendicular? That is very important, students. You will face it in physics, in higher classes, even in 12th class, even in 11th class. So f into r perpendicular. When there is formula of work, then there is work done is equals to f dot s. So we write it s f into s parallel, or s into, because that is s into f into cos theta. Okay, and that's equals to, we write it as we further write it as f equals to, see, in this case, do you remember this was your s and this is your f? So the projection on the s, and this length is f cos theta. Okay, this length. So this was your s, and this length is your f cos theta. This was your f cos theta. So you multiply these two. So here f cos theta, so s into f parallel we take. So that's the difference here. Means if we project s in the direction of f, if we project s in the direction of f, then how do we write it? Then we write it as f into s parallel. So displacement in the direction of force. So that is what the work done is. Okay. Yes, you can project the displacement on f also. So these are the two important ways of writing the dot product and cross product, writing their magnitudes. So this is, here we have s parallel and here I have r perpendicular. So what is this meaning of this r perpendicular? Means you extend force, this is your line, extend the force line, extend this.
Sir,
Yes, line of action. Yes.
please accept Randir Sharma.
Sorry.
Sir, Randir Sharma wants to join the class.
Who wants to join the class? Randir Sharma. Okay. But he is not joining it from his school account.
Sir, he does not have a school account.
He does not have the school account. Okay. Don't know what's the matter. So you can see this name on your screen also. Karthik?
Yes, sir.
You can also see his name on your screen also, that he wants to join the class.
No, sir. अभी उस मैसेज किया सर उसने मेरे को.
Okay, he has sent you the message.
Yes, sir.
Okay, so I don't know what's going on. means my I am unable to help him out due to some reasons. Okay. So unless and until he has the school account, Karthik, and just tell him to join from the school account only. Okay.
Okay, sir.
He can talk to me later because okay. Let me try this time. What's his name?
Randhir Sharma.
Randhir,
Yes, sir.
just show me your face.
Please, sir. Yeah.
Okay, fine. See, join from school account only from tomorrow, okay? If you have any problem, you can just message me. I will send you the password again of your email, okay? School, you have your school email and you have your password also, okay?
Yes, sir.
So, Mansi, do you have any questions?
No, sir.
Okay. So, students, these are the two important notations: dot product and cross product. Okay, so here we have the means S parallel or F parallel into S. We can also write it as S means F parallel into S, means here both the components are in the same direction. Okay, and here one component is perpendicular to other. Okay, so that's the difference, right? So I can also write it as F perpendicular into R, means the perpendicular distance between means this force and R. Okay, so that can also be taken. Okay, now here I will draw the perpendicular from this point on the line of action. This is my perpendicular I have drawn, and this distance will be what? This is your R, and this is the opposite side to theta. So opposite side is equals to hypotenuse sine theta. So this opposite side, this hypotenuse is opposed to 90 degree. So this is opposed to 90 degree. This is R. So this opposite side is equals to R sine theta. Randhir, you definitely you will have some means some issues for next couple of days, but everything will be normal. Okay, so it will be very difficult for you to understand the concepts because you are joined in the middle. Okay, so have some patience. Watch the classes regularly and watch the previous videos also that are there on the YouTube. Okay, so watch the previous video and attend the class regularly. You will be able to understand. So don't give up. Okay, you are a brave boy. So opposite side, so this side is R sine theta. So that's what this R sine theta. So what this R sine theta is? So R sine theta is you are extending the line of the action and you are drawing a perpendicular on it from the point where you have taken your the origin where you have taken your position vector R. So this is R sine theta. So you are multiplying this magnitude F into R sine theta. So you are multiplying these two. Okay, this is your R. So now let us see here this application of torque. This is your hinge. So this is the top view of your door. This is the top view of door. Now if you look at the door from the top, this is your hinge, this is your axis of rotation also. So this is your, so axis of rotation is coming out and going into the plane of the paper, means it is going into the plane of the paper, in fact, because this is a top view. So this is the axis of rotation, and here it is going into the plane of the paper. So this door or axis is, it means the hinge is this is at the top view. So axis of rotation is, of course, it is coming out, going in. Axis of rotation is perpendicular to this plane of the paper. Okay. So student, this is simple your door, like door of your room. Okay. So if you are applying the force on the hinge, okay, tell me, will the door move? Yes, will the door move?
No, sir.
No.
No, sir.
Okay. Why the door will not rotate? Because here we have rotation. The formula of force the torque we have is tau is equals to RF. Let us write only the magnitude. Direction doesn't matter. It is perpendicular to the plane containing R and F. Okay. So in this case, case A. Okay. So what? So the door will not move. So R. What is R here? What is the value of R in figure A?
0.
Okay.
0.
0. R is 0. So the distance between the application point where you are applying the force and the axis of rotation. So you are applying the force at the axis of rotation. So R is 0. Okay. So R is 0. And the second thing is, what is theta? Because you know F. The only problem you will have is R and theta. So if R is 0, of course R perpendicular is 0, so torque is going to be 0. Even you don't need theta, but still, what is theta here?
So 0.
Yes, theta when R is 0, so of course the angle will not be there. It is actually not defined, right? 0 you can say, or not defined, means not applicable here, sort of thing. Okay.
Yes, sir.
Okay. Second is now look at this figure now. So here I am applying the force at this point. So what is R? What is R here? This is your axis of rotation. This is the point where you are applying the force. This distance is R. Okay. Any problems? What is
No, sir.
what is theta here? Okay, R is there.
9.
R is there. What is theta?
90.
90.
See, where is your always don't be in hurry. Always draw the always draw the line of action. So that's your line of action. Okay, that's your line of action. And this is your point origin, axis of rotation. Okay, so the perpendicular distance. So here you can see this distance is already perpendicular distance. So here R and R perpendicular are same. Okay, so R and R perpendicular is same. So R, and what is R perpendicular? R perpendicular is your R sine theta, and that is equals to R. So it means sine theta is 1. So sine theta is 1 when theta is 90 degree. So in any way you can just check it out. Okay. So here this angle is 90 degree. Okay. So here the theta is 90 degree. So when the theta is 90 degree, you will get the when is the torque maximum? So torque is maximum when theta is equals to 90 degree, right? Because this will be equals to 1 and the maximum value of sine is 1. Okay, so torque is maximum in this case. Now let us see figure C. Now you are applying the force in the middle of the door. So what's this distance? So if
R by 2.
yes, r by 2. If you are considering this distance as r, this whole distance as r, so now the distance r is r by 2. So you can say r dash. This distance is what you will say, this is r dash. Okay, so r dash is r by 2. Okay, and where is the line of action of force? That's your line of action. Again the angle is 90 degree. So theta is 90 degree here, but your r dash is r by 2. So here the torque, so torque will also change. So torque t dash, tau dash you can write, that's equals to r by 2 f sine 90 degree, and that's equals to tau by 2, right? So half of the torque. So if you are reducing the the perpendicular distance, then the torque will also be reduced. So the torque depends on this perpendicular distance and force, right? So either write r perpendicular or write r sine theta. Both are same thing. So write one of the things only. Don't write both the things. So this is either write r sine theta or write r perpendicular. That's your choice. Now in this case, D figure, what is the angle here? What is r?
R.
Means your this perpendicular distance is, this is the same here, the r. What is theta here? What is the line of action? This is your line of action. So what is the angle between what is the angle between r and line of action?
180 degree.
180
degree.
180 degree. This is your r. Very good. This is your r and this is your f. So you have to join them from their tails. So this is r and this will be a direction of force. So this will be a direction of force. So the angle is 180 degrees. So theta is equals to 180 degree. Again, will the door rotate?
No, sir.
No, because sine 180 degree is equals to 0. Okay. So if you look at the sine curve, this is theta, and here we have on the y-axis we plot sine theta. So this is the graph that you are going to get even in both sides. Okay, so here negative theta, this direction, this is positive theta. So this sine theta is maximum at pi by 2. So at 90 degree it is maximum. If you increase this angle or decrease this angle, means increase it towards 180 or decrease it towards 0, the value of sine will 0. So if the angle is less than angle is between 0 and 90, still the torque will decrease as compared to the maximum torque, and here again the torque will decrease and the torque will be 0 at the angle pi and when the angle is 0. Okay. There can be one more case, that is case E, which is there over here. Means this is your hinge and this is your door, and now you are applying the force actually means here in this direction or here in this direction, in any of the case, means not. So here in both the cases you will have this angle will be theta or this angle will be theta. Okay, so in both the cases, here in one case, see, this is your R and this is your F, right? So these are two cases actually. Okay, so let us take these two cases differently. Let us take these two cases differently. Okay, let us take this case first. This is our case E. Okay, this is case E. Now tell me, in this case, what's this angle? If this angle is theta, what is the angle between R and F? R perpendicular. I want to know R perpendicular. R perpendicular is R sine. What angle you are going to take? Yes. What is the angle here?
180 minus theta.
Yes. Because see, this is your F and this is your free vector. You are going to take this free vector over here. So this is your R. Okay. So this angle, or you can bring the F here. Yes, bring F here. Yes. This is a line of action. No. You cannot bring it here. You can bring it here. This F, right? Joining with tails. You can bring F here also. So the angle between this is theta. This is 180 minus theta. Okay. So the angle will be 180 minus theta. So again, there will be lesser torque, right? Torque will again be reduced if you apply the force. So this is now what is the figure which is there in our book? That is figure F, which is there in our book. Okay, this is the hinge and this is the door, and you are applying the force from here. So you can write it here, or is this clear? Not applying the force perpendicular but at certain angle. Okay, is it okay? This is your R. So this figure you can also draw it like this. Okay, so this is the force you are applying. So now if you are taking this angle as theta, so is it going to matter? This is your R and this is your F. So this angle and this angle is the same. So here the R perpendicular is R sine theta. So which is there means this case is your NCERT. So this is case F. So students, we have discussed almost all the possible cases, and I hope you have understood this concept well. How to write it, and when will the torque be zero? So torque will be zero only when in the cases when R is equals to 0, or when theta equals to 0, or theta equals to 180 degree. So then only the torque is 0. So here in this case also the torque is 0 in case D. So here no torque because the theta is equals to 180 degree. Here there is no torque because R is equals to 0. And if the angle theta is 0, so how can angle theta be 0? If you take one more case, G case, in which theta is equals to 0, how will that case be? See, that's your hinge and this is your door. Okay, so this is your means. So how can this so this is, suppose you are applying the force here, so this is R. Now you have to apply the force in the same direction as R. So actually you are applying the force which is not practically possible, okay. So but assume that you are applying the force from this side. Okay, if you are applying the force from this side, so not in the case of door, but it can be there in some other case. So here the theta is equals to 0 degree and torque will be 0. So this is the case G. So students, please write down all these cases. Okay, so this is case G, this was your case F, and this was your case E. So I hope this the concept of torque is clear to you people. You can take a screenshot of it. You can now the next topic that we have is angular momentum. Okay, so just like we have moment of force, we have a moment of momentum. So we call it moment of momentum, or you can say moment of linear momentum. And what do we say it? Angular momentum. Okay, so here so similar term I have is moment of momentum. So here of course this force was also linear force. So moment of momentum, and that is angular momentum. Okay, so moment of momentum, which is angular momentum we have. Okay, and what is this angular momentum? That is simply L equals to R cross P. Okay, so just like here, the torque is equals to R cross F, moment of force, we have moment of linear momentum, that is L equals to R cross P. So same L is equals to, you can write it as the magnitude will be R P sine theta, and direction of L will be perpendicular to direction of the plane containing R and P. So here also you can write L equals to R perpendicular P or P perpendicular R. So you remember you have the formula P, that is equals to M into V. So here you what is the means in rotational motion, your angular momentum will be written as L equals to, what is M? What do we replace with M? We are going to study moment of inertia in detail. Okay, so what do we have? I, and what is V? V is your omega, right? So here linear velocity, here angular velocity. Now what is F equals to? dP by dt, right? Newton's second law. So similarly here what do we have? If we are replacing both of them with the moment, both the force and P with moment, what do we get? Tau equals to dL by dt. You can write it in vector form also, no problems. Is it okay, students? So that's what moment of force is. A moment of force and moment of momentum. So the only thing you need to understand is that here this was the net external force, yes, and here also this is the net external torque. So I'm not talking about the internal forces, they cancel out each other. So in the case of torque also, so contribution of the internal forces to the total torque on the system is 0. Okay, so tau internal is always, so this is only tau external. Why? Because tau internal is equals to 0. Just like we had F internal is equals to 0. So similarly, tau internal is also 0. So whenever I am writing F or tau, it means net external force. Always remember this thing. And if students, if this is equals to 0, if suppose F external is equals to 0, what does this mean? It means, this implies therefore P is constant. Okay? Yes or no? Students, what if tau external is equals to 0? If tau external is equals to 0, then what
L is constant. L is
F is
equal
equals to
to
constant. Very good. So students, that's all. We have done till page 157. So you can read from your book. Simple. If you want to derive these relations, you can derive it. I have told you the concept. So page 157, up to page 157 we have done. So just read them out and derive the relations. Very easy. You will not have any problems of any kind. And we'll do example 7.6. You can try it out yourself, and if you want me to do, we'll do it tomorrow. So sort of revision. So tomorrow's class is very important because we will be doing equilibrium of rigid body. You are definitely going to have a question in your exams also, equilibrium of a rigid body. Very important concept. So students, I am telling you, see that these topics are very important.